Alright guys, welcome back. This is part 2 of chapter 3, section 8. I had to stop because the video was getting pretty big. So we have one more inverse trig function to derive right here, and that's the derivative of arcsecant, right? Derivative of arcsecant. Now, we find that the derivative of y equals arcsecant of x with x greater than 1, beginning as we did with the other inverse trigonometric functions, okay? So basically we start the exact same way as with arcsine and arctan, okay? So y equals secant negative 1, or arcsecant of x, sorry. And so we use the inverse function relationship for the third time today, and we get secant of y, sexy right there, equals x, okay? So what we're going to do is we're going to derive both sides. Secant of y equals dy dx x. Okay, and you should know that the derivative of secant of y equals secant of y times tangent of y. So the derivative of secant of y, I'm just going to reinforce your memory everywhere you go so you don't forget by your next test, okay? And this is, of course, there's a dy dx attached. So let's move that part right here. So right now we have secant y tangent of y dy dx. That is equal to 1, okay? So what are we going to do? We're going to find dy dx. Dy dx equals 1 over secant of y tan of y, okay? So since x is greater than 1, right, we mentioned that up here, since the absolute value of x is greater than 1, y lies in the range, so y lies in the range 0 to pi over 2 union pi over 2 to pi, okay? And secant y tangent of y can never equal 0. That's why we can make such a division, right? We don't want undefined fractions, okay? So in order to express the result in terms of x, we use the relationship 1 plus tangent squared theta. I'm going to use theta here, right? Secant squared theta, okay? And so we soon realize that, as we mentioned here, so this is one equation that you have to be aware of. And the other one is that tangent of y is equal to plus or minus the square root of secant squared of y minus 1, which is also equal to plus or minus x squared minus 1, right? Because you simply substitute secant of y here, right? This becomes x squared minus 1, so plus or minus x squared minus 1, okay? And so what you do, and so what you end up getting is you end up getting dy dx, right? So your dy dx is 1 over secant of y times tangent of y, right? So now your derivative becomes, so now this gets replaced by x, okay? Secant of y gets replaced by x, and tangent of y gets replaced by plus or minus root x squared minus 1, right? And since we have, and since we can't just do, or here, I'm just going to put a plus or minus sign in front just to make this easier. And we're going to now put x squared minus 1. Okay? And that's your derivative right there. Now, you're probably asking yourself, can we do anything about the plus or minus sign? Well, at first, so if we were to expand this, it would be a piecewise function, right? You would have a big bracket right here. And it would be for positive, then it's x greater than 1. And for negative, it would be x less than negative 1, right? But with the absolute value symbol, we can write a single expression that eliminates the plus or minus ambiguity. So what we're going to do is now we're going to write dy dx, right, equals 1 divided by the absolute value of x times the square root of x squared minus 1. Okay? So this is your rule right here, and of course the absolute value of your x has to be greater than 1, right? So x has to be greater than 1, and negative x has to be smaller than negative 1. And so this is your differentiable function, and this is your derivative of arcsecant, excuse me. So that's dy dx equals 1 over the absolute value of x times the square root of x squared minus 1 for all x's with absolute values greater than 1, okay? We're going to do an example right now just to reinforce the concept, and this is example 3, okay? And it's asking us to find the derivative, ddx, of secant, or arcsecant of 5x to the 4th, okay? So this equation right here, I actually have the cheat sheet right next to me. I got this cheat sheet, right? And so the equation's right there, right? We're going to use this to help us, okay? And so we have this right here. And what we're going to do is, this is equal to 1 over the absolute value of your u, right? U being this inside function right here, right? Times the times the square root of u squared minus 1. And in order to obey the chain rule, you also have to multiply by the derivative, ddx, of 5x to the 4th, right? Because that's the inside, right? You got to peel that part too. Okay. So what you're going to do is, once you get to this step, you're going to open everything up. So you have 5x to the 4th. You know that it's never going to be negative because everything raised to the 4th power will always be positive, right? And on the inside, you have the square root of 25x to the 8th minus 1. All of that multiplied by 20x to the 3rd. You move that up there, your x's cancel, your 5 and 20's cancel. So in the end, you get 4 over x times the square root of 25x to the 8th minus 1. Okay? And that's your that's this example number 3. It's asking you to solve a derivative with arcsecant and the chain rule. Okay. Now we're going to do the inverse functions of. Now we're going to do arc cosine and arc cotangent and arc cosecant. And by the time I finish with that, you're probably going to be fast asleep. But which is why there is a much easier way to do it, thanks to the following identities right here. So if you were to find, or if you wanted to find the inverse trigonometric, if you wanted to find the derivative for the inverse trigonometric functions listed here, that's arc cosine, arc cotan, and arc cosecant, then you simply take pi over 2 and you subtract it by whatever it is, because these are cofunctions and they're only off by pi over 2, right? Because if you can recall, your sine function looks like this, right? Sine crosses right here, right? Looks like that. And then your cosine just is moved over by that much, okay? And they simply miss each other by pi over 2. Which is why you simply do not have to derive 3 new functions, or 3 new inverse functions, right? Because this is going to mess up in your memory and you're going to have a lot of trouble remembering 6 different inverse functions, okay? So just remember these 3 right here. This is arc sine, this is arc tangent, and this is arc secant. And in order to find the inverse cofunction, you simply take pi over 2 and subtract it by the respective cofunction identity.